Hey guys, Bukoid here. Do a video for you guys. Hey, I did a video and forgot to turn the audio on, so I gotta redo it. But yeah, we had a 6.8 earthquake earlier today. That's what I'm going to talk about here for a second. We've had 7 6+ in a week. That's way above average. Dutch just did a video on it a few minutes ago. He said the same thing. We're supposed to get like 1 or 2 a week, I guess. And then sometimes it'll skip a good time frame, and then we'll get some more, that kind of a thing. But 7 in a week is very, very elevated. This one that struck in Chile was very shallow. It was at 11 kilometers. Okay, the closer to the surface that we have the epicenter is, the more shaking and feeling that we actually feel on the surface. Okay, does more damage, it's way more dangerous. I haven't seen any reports yet. I haven't really looked. I don't know if there's any casualties and stuff. Sometimes I don't like to look at that, guys, because simply it just brings me down. I don't, no other way to put it. I usually look at it anyway because I want to report to you guys what's actually going on. I do think it's important to include the solar weather, space weather, into those models. Okay, they're starting to do that. Okay, USGS and NOAA actually came out with a brand new model that I put at the end of my model update. It shows the geomagnetics just in the States, but it shows it in regions how it's actually moving a little bit, moving around, the intensity of it. So, and I'll show you guys that later. But back to this. Okay, this radiation. I'm not saying that we actually had a magnetopause reversal here, because I'm not sure if it's actually the truth, because this isn't really our magnetopause. This is our radiation belts. But I'm not sure what, I think that, to me, it looks like that's our bow shock. Okay, it would make sense because that's what would protect us from that radiation. So watch what this does. Okay. Now I'm going to toggle it through. You're going to see some big pinks and stuff there. Pink is the highest it gets. Okay. It's about right there. She's getting red. Okay, do you guys see that? Look at that. Look what that just did. I'm going to take this back so you guys can see there's the pink. You see that intense radiation? Now this is at the 50 model here. Okay, it goes up to 2,000, 4,000, I think is the highest it shows. But anyway, we'll go through here like this. Now, if this happened on our magnetopause models, and actually we've seen that flip like that, that would definitely be the magnetopause flip. And that's what that information was that was scrubbed from the net. Okay, happened in 2012. All that stuff, I worked close with Scott with this, and he gave me some information and stuff, helped me understand it. And, I did a video on it a while back. And there's some science behind what happened there, but it's our magnetopause did flip. And, went from over here to over here for a good time. Like 12 hours, I think. Really crazy. But you can't find that data anywhere. Scott was forward thinking enough that he recorded it, and I think Terrell Blackstar did also. I'm not sure who else did. I'm sure there was probably a couple others that are, forward thinking and ready because they've been around this for a while. But anyway, back to this. As we get going here we go. Okay, what you're going to see that? See how it moved? Like you could see it actually flipping over. I don't want to use that word flip. It's moving that direction, I guess I should say. So as we go forward, it kind of goes back to normal. And then we get one of those numbers. Oops. That completely filled that screen. I've never seen that before. Okay. Except for when it did that flip back then in 2012. And then look what happens. Okay, so we go from here to there to kind of trying to go back that other direction, and then boom, right back that way. Okay, so I don't know what's going on there, guys. Did it flip over? I mean, that's what it looks like, but I'm not sure about the science behind that yet on these radiation belt models. But I just wanted to show that to you guys. Alright guys, this is the Australian magnetopause model. Yeah, I show this sometimes. but it's doing something I've never seen it do. Okay, let me stop there. I did an interview over at Forbidden Knowledge News last night. Guys, go over and check that out. I'll leave a link to that video. Chris Matthews did an interview with me. If you guys want to know what blue Kool-Aid looks like, go over and check it out because I was on camera. I've been on camera before, but, you know, not very often. So, as we're doing this, what I want you guys to pay attention to here. First off, the protons. Okay, centimeters to the third power is what that unit of measurement is. That's very low to begin with. You know, that's very low to begin with, but it gets even crazier. Okay, normal would be like at a 3 or 4, not 0.3. Now, again, you're going to see something here I've never seen happen on this model. See how that's expanding out? Watch what it does. See how it kind of almost even went off the screen there? Look at the protons, 0.1. Now, that ain't it. Okay, it's trying to bounce back in. Does that, pops out again. Look at the proton level. Went down to 0. I don't even know how that's possible. Now, I would think that if you extended this out numerically, it would be like a 0 and a 3 or something to the thousandths, right? So there's probably some protons there, just this model can't show it. So I'm going to go forward again. Okay, it's hanging out right there. Now look what happened. Absolutely nothing on this graph. Did it disappear? I don't think so. What I think happened was it got expanded out enough that it was like out there. Okay? Regardless, it should not be out that far. It usually hangs out right here. Okay? So that's way crazy. At the same time that I just showed you guys that radiation belt thing. Yeah. So if I play this, you're going to see it bouncing around. Look at that. Okay. Now, what does this mean? Again, guys, I'm just showing you the observation. I'm not sure if it actually flipped around or not. Doesn't look like it did, at least on this one, because if that was the case, it would go back here, right? But our shields definitely went out that far. Now, is that what that radiation belt's showing? Is that expansion out in the front? I don't know. But that's just the observation I made. So I'm going to pause it here again. All right, guys, this right here is a space weather model. Okay. Yeah. Anyway, guys, this right here is that geomagnetic storm. Okay. This one actually just updated. It was showing some few hours back here. It was kind of like looking like this. Okay. It steadily rose and then up to it and then kind of rose back down. And that's exactly what we would expect. And then it kind of popped back up here. Looks like it's going back down now too, though. And that could have been like one of the smaller coronal holes that was right behind this coronal hole that gave us this event. Okay. But I wanted to show you guys that. Now, this right here. This was kind of nuts in my mind. Okay, it's the electron flux. Daggone it. This here, and so doesn't really concern me a whole lot, but that is kind of a good spike. When this goes down, that means the actual electrons actually went up. Okay, that's what this means. But what I'm talking about here is the distance that it moved in such a short period of time. It's like we had a bunch of energy there, a bunch of particles, and then it just dropped out to nothing. Now, let me show you guys something else here. Okay, this is one of the Magnetosphere models I show you guys. Okay, sun's over here on this one. Sorry about that. It's over here, towards the left. All right, it's reverse of the other one I show you guys. Okay, now what I want you guys to pay attention to is over here, up in this area. Okay, if we're getting hit directly from the sun, typically it hits us right on the chin, right in the front. Comes this way. So when it hits our magnetopause, our shields, our magnetic shield, it goes around it. So what I'm saying is that it's pretty symmetrical. It should kind of do the same on the top as it is on the bottom. That's not what I'm seeing here. Okay. Now I'm not saying that we can't have solar winds that are kind of coming at us at an angle maybe that cause this, but this seems to be more directional than what it normally is. So again, right in here, see that how it's waving up there? Boom, it's going that direction. Okay, now I have to say this too, okay? It could absolutely be nothing. It could be very normal. But it definitely looks like it's blowing that way. And I don't want to use the word blowing, okay, because it's not really blowing. It's charged particles moving at a certain speed. Okay, that's what the solar wind actually is. It's not like blowing like wind we would think here, okay? It operates different. So I'm going to play it again, so you watch it. And when it does that on the top, it's not doing nothing on the bottom. Plus, look at this. Let me back this up some. Okay. Look at this. And this one's showing the same type of thing over here. So, I mean, it's definitely directional there. Is that coming from the sun or something else, or what's going on there? It just seems like everything's getting skirted off that direction. Okay. Now, I just showed you the Australian model, right? I was talking about the density. Look at this. Okay, this model's playing right now, guys. Look at that. We should be seeing like different colors, right? And we see a little bit there. Now, when you see white on this graph, that means there's no density at all. Okay, when it's like bright white, the density is really low. And when we have darker, you know, it is what it is. So, you know, then we got to talk about the pressure here that's being caused by all that, right? So the pressure would go down. So if the pressure goes down to that extreme, like up here, and that's showing density. It's not really pressure, but if I ran this model down here, you would see it almost go away. So what happens in my mind, you know, the Earth's still pushing out a little bit, because when we're getting pressure from all directions, we have to push out just a touch to keep our middle ground, okay, to stay stable. So when that pressure is released on the outside of us, I think we kind of expand out just a touch when that happens. Now that could, in my mind, I think that could contribute to some of the uptick in earthquake stuff, volcanoes, all those kinds of things, right? Now, is that actually how it works? I'm not sure. So to explain it kind of in a little bit of layman's terms there, what I'm talking about is, remember when you were kids, or maybe not even when you were kids, when you're pushing, like say one of your friends, you guys were like pushing against each other, right? Trying to go forward. Reverse of a tug of war. And then one of you guys decide just to stop pushing and move out of the way. What happens? The other guy is still pushing, so they lunge forward and fall down, right? So that's kind of what I'm thinking here. Is it the way it actually works? Not really sure, but that is kind of how I understand it. If that actually does happen that way, if there's science behind that, but I could see it working that way, but I could be wrong. But yeah, so I think I am going to end the video here, guys. Yeah, I'll try to give you an update again. There's a model update here. At the end here, I think we do have to keep the earthquake stuff in our minds, because I think the geomagnetic stuff and the solar wind stuff is still going to continue, at least at a heightened level. Maybe not storm level, but I think because we got another coronal hole that's Earth facing right now. So I know that in like 2 to 3, maybe 4 days, we're going to get some winds off of it. So we should be expecting those kinds of things. And again, guys, you know, I wanted to show you that radiation thing, because that was kind of crazy, and all that stuff's tying in, because that radiation model is doing its thing at the same time that the Australian model was showing our shield getting pushed way out. So is that what's going on there? I don't know. I don't think our shield went away. Okay, I don't want anybody to think that. I think it just went off of that graph. So, but I will end it there, guys. God bless. She saves, and you can drink this Kool-Aid.
Someone told me long ago, there's a calm before the storm. I know it's been coming for some time. When it's over, so they say, it'll rain a sunny day. I know, shining down like water. I wanna know, have you ever seen the rain? I wanna know, have you ever seen the rain coming down on a sunny day? Yesterday and days before, sun is cold and rain is hard. I know, been that way for all my time. Till forever on it goes, through the circle fast and slow. I know, it can't stop, I wonder. I wanna know, have you ever seen the rain? I wanna know, have you ever seen the rain coming down on a sunny day? Yeah! I wanna know, have you ever seen the rain? I wanna know, have you ever seen the rain coming down on a sunny day? In a lifetime made of memories, I believe in destiny. Every moment returns again in time. When I've got the future on my mind, know that you'll be the only one. Meet me halfway across the sky, up where the world belongs to only you and I. Meet me halfway across the sky. Make this a new beginning of another life. In a lifetime, there is only love, reaching for the lonely one. We are stronger when we are giving love. When we put emotions on the line, know that we are stop it.